Good day everyone, Mr. Cargill here with our next AutoCAD video. Now in this video we're going to be looking at 30 technical drawing multiple choice questions. Now these questions are from the CXC technical drawing syllabus on the specimen paper, which you can get from the CXC website. Alright, and the answer sheet is also in the syllabus as well. We're going to look at, this paper consists of 60 multiple choice questions, but we're going to do 2 sets of 30. So we're going to do, in this video we're going to look at 30 of the multiple choice questions, then in another video we'll look at the last 30. Alright, so for number 1 here, let me just zoom this in a bit. Alright, it says in an isometric sketch, circles and arcs will appear as, and the answer for this is C, ellipses or parts of an ellipse. Alright, and we know that isometric sketch or circles will appear as ellipses or parts of an ellipse, because even in AutoCAD, if you were to draw an isometric circle, so let me put that in the isometric grid. If I select E for an ellipse, alright, and then if I want to use that ellipse to draw an isometric circle, right there, I select ellipse, and then it gives me the option. It says, do I want to draw an arc, center, or isocircle? And I would select I for isocircle, and then I will be able to draw my circle in isometric. All right, so in isometric, circles and arcs will appear as ellipses or parts of an ellipse. All right, number 2. Which of the following instruments is used to draw irregular curves? In this case, it would be a flexicurve. All right. Good. I don't think this one really needs much explanation. We use a flexicurve to draw irregular curves. Which of the following triangles show? Sorry, which one of the following drawings? Shows triangles of equal area between parallel lines. The answer for this would be A, and this is why it would be A. It's because that triangles that have the same base and the same height will be equal in area, and A is only this example here in this drawing shows that these two triangles have the same base, which is M to N, and then they have the same height right here. All right, that's all the other triangles are different. So we can look at this in AutoCAD. If we have a line here, let me come out of the isometric grid. All right, so if we have a line here, let me turn on ortho. So we have a line there, and then we have a next parallel line here. Okay, if we were to draw triangles like this, so let's say I draw a triangle like this. Let me turn off ortho. I do that and I do that. Now if I draw a next triangle that has the same base, so let me just complete this triangle like that. All right, so if I draw a next triangle with the same base, all right, and the same height, they will always be equal, even if the next triangle is from that point to this point here. Triangle here, the last one that I drew, will share the same area as the triangle here, as long as they have the same base and the same height. It doesn't matter if the next triangle is like over here and something like that. Alright, they would still have the same area. It doesn't matter which triangles are, as long as they are on the same base and the same height, even if that was a triangle. Alright, all of them would be equal in area as long as they have the same base and the same height. Okay. Alright, now for the next question, question 4. It says, in the drawing above, which of the following letters indicates the center of the arc which is tangential to the 2 circles? And the answer for that would be O. Alright, and you can see that this is the arc here that is tangential to the 2 circles, and then we see O right here where these 2 arcs meet, and we have an arrow that is pointing to this arc right here. So we know that O would be the center of this arc. Alright, so this answer is O. Alright, item 5 refers to the following views. So this is item 5, and these are the views right here. It says, which of the views below shows the plan of the object illustrated in two views above. All right, so this is like a side view or a front view, and then this is a plan view. Okay, so now which would be the actual drawing for this if we were looking at this from this view? All right, when you're looking down on this, okay, we'll see this circle that would be represented with two lines, right? So we'll see this circle being represented with two lines. So we need to have two lines in the middle. All right, all of them have two lines in the middle, so we know that. So the next detail that we need now is we have this part out here, so we'll have this, and we'll also see this line. So we'll have this, and then we will have a next line here. All right, so something like that, or like this. So these are our two candidates. These two, A and B, would be eliminated. The reason why for that is that we'll see one line here and a next line here, but this is only showing one line. These two are only showing one line. All right, so the only other candidates are C and D. But our next thing now is we're just using the process of elimination. So we'll see this line right here, okay? We'll see that as a solid line. So being that we'll see this as a solid line, it means that the answer could only be C, all right? Because this is showing this as a broken line. But if we're looking down on this, this will be represented as a solid line, okay? So that means that the answer could only be C. And we also know that C is the answer because we'll see the circle, this all through the figure being represented in broken lines. All right, and see we see the broken lines here, but for D we don't see any broken lines. And we have the answer sheet here, so we can double check, we can cross-reference to see number 5 here. It says that the correct answer for number 5 is C right there. Okay, good. All right, number 6. Which of the following correctly defines the locus of a point? Is it the calculated circumference, a point which moves and traces a path, the cutting tool attached to the lathe, a right-angled triangle wrapped around a cylinder? The answer is B. A path which moves and traces, a point which moves and traces a path. And we looked at different loci. We looked at different loci drawings. We looked at the Archimedean spiral. We looked at the cycloid. We looked at the involutes of a square, involute of a circle, and we did all of those drawings already. So yeah, that's what I mean by locus. It is a point which moves and traces a path. All right, so number 6 would be B. Number 7, which of the following circles is correctly dimensioned? All right, I want you to think about the answer before I show you what the answer actually is. Which one of these would you say is correctly dimensioned? So this is number 7, and according to the answer sheet, number 7 is A. Okay, see, number 7 here is A. All right, and we know that this is A because the arrow goes from one end of the circle through the center of the circle to the next end of the circumference, and the diameter symbol is used to represent that we're talking about the diameter, and we're saying that the diameter is 36. All right, so that is properly dimensioned. So the answer for number 7 is A. All right, number 8 refers to the following diagram, this diagram right here. It says the polygon shown above is a regular hexagon of side. So we're trying to work out what is the length of one side of the hexagon. So all we're given is the circle that surrounds that hexagon. So how can we use that information to determine the length of one side of the hexagon? All right, if the diameter is 95, then the radius has to be half of that, which would be 47.5. all right, so that's number 8. So let's see what number 8 is. Number 8 is A. Yeah, so the answer is 47.5. Now in AutoCAD I can show you how we would get 47.5. all right, so we're going to select a hexagon. We're going to select a polygon, sorry. You're going to type polygon. All right, we're going to select a polygon, and then it says enter number of sides, so we're going to type 6 and press enter because we want 6 sides. All right, so specify the center. We want the center there. Okay, and then it's asking us if you want the polygon to be inscribed in the circle or circumscribed about the circle. We want it to be inscribed in the circle, like the one in the on the question paper. So we're going to select inscribed because we want it to be inscribed in the circle. Okay, and then specify the radius for the circle. All right, so the radius for this circle is going to be 47.5. Let me just turn on ortho to ensure that it's straight here. We're going to use 47.5 and press enter. All right, and when we do that now, we have this hexagon. Now, if we were to draw a circle around this hexagon, okay, then that circle would have a diameter of 95, and we can check that by drawing a circle from the center there to there. Now, if we were to measure this distance from one end of the hexagon to the next, this should give us 95. All right, and it says it right here, 95. All right, so the answer is 95. So the diameter of the circle would be 95, which means that the radius would be 47.5. But the question asks us about the length of one side. So the length of one side, sorry, should be 47.5 when the diameter of the circle that would surround it is 95. So we can measure the length of one side. So let's see. The length of that side from there to there is 47.5 right here. It says the distance is 47.5. So we are sure of the distance. So we are now 100% certain that the answer for this is A, 47.5. All right. Now, item 9, it says that item 9 refers to the following diagram. The triangle illustrated above can be constructed with the use of what? Is it A, a ruler and a pencil only? B, a compass and a protractor only? C, a compass, a ruler and a pencil? Or D, a set square, a ruler and a protractor? Well, immediately we will know that B and D would be ruled out because you need a pencil to draw the lines, and since those answers don't have any pencils involved, then it can't be B or D. So we're left with A and C. A says a ruler and a pencil only, but we know that we would need also need a compass to get this angle right here. All right, so the answer would be C, a compass, a ruler and a pencil, and we can cross-reference that in number 9, C. All right, so we would need a compass, a ruler and a pencil. Number 10. Which of the following is a view of a right triangular pyramid? All right. No, it cannot be B, because B isn't a pyramid. It's a prism. All right. A pyramid would come to one point at the top like all the rest of these. But A couldn't be the answer either, because A is a cone. All right, so it can't be a right triangular pyramid because it's a cone. So we're left with C and D. Which one do you think it would be, C or D, before we figure out the answer? All right, according to this, number 10 is C. All right, so number 10 right here, the answer is C. So if you ever see that question anywhere again, you know what, which one of these show the view of a right triangular pyramid or anything like that involving a right triangular pyramid, you will know that in a like isometric view, it would look like this right here. So this is our right triangular pyramid. All right, C. Good. So now for number 11, which of the following represents the correct procedure for bisecting an angle? Is it A, B, C, or D? All right, just look at it correctly, or just look at it in depth and see which one of these methods would you use to bisect an angle, sorry. And then we'll see if your answer matches the correct answer. All right, so number 11 would be B right here. Okay, so number 11 is B, and the reason for that is this: it could not be C. You probably would have thought about C, but for us to bisect an angle, so we're bisecting this 90-degree angle right here. So first you have to construct the 90-degree angle. All right, and to construct the 90-degree angle, we'd have to construct this right here with the 60 and the 120, and then bisect those and get the 90, and then bisect the 90 to get the 45. All right, so the answer right here would be B. Good. It could not be C because we don't have a point down here to use, or a point up here to use to bisect to get the 45-degree angle. Okay, and right here at D, this is a 60-degree angle, so we're not bisecting the 90, we're just creating a 60-degree angle. Okay, so the answer has to be B, because in A we're not bisecting anything either. All right, number 12. Which of the following represents the plan of the drawing above? So the plan view, what would you be seeing when you're looking down on this? All right, so immediately we know that it cannot be A. All right, we know that it cannot be A because this would look flat like a square. It wouldn't be going at an angle like that. All right, and we also know it couldn't be A because this section right here would be represented in broken lines, and we're not seeing that being represented in A, so it could not be A. All right, we know it could not be D either because when we're looking down on this would look like a flat surface, so it wouldn't look anything like this, so it cannot be D. We also know it cannot be C. Why do we know it can't be C? Because for C here, this line here is way too close to this line, because what this line represents is this point right here, and then we have this line going across there that would be represented in broken lines, but this is way too close, so we know it cannot be that. Also, we know it cannot be C because this part is closed off, while as you can clearly see over this section here would be opened, and we will not be able to see the circle as a circle. It would look like a line, like this broken line you're going through B. So with the process of elimination, we know that the answer would have to be B in this case. All right, and we can check that. So number 12, the answer is B. All right. So number 13 here, which of the following patterns could be folded to form a truncated square prism having no cover or base? Now this is a surface development drawing, and we do have a surface development playlist on the channel that you can watch if you're interested in that topic, or if you're doing that topic right now in school. And so this is asking us which of the following patterns could be folded to form a truncated square prism having no cover or base. And the term truncated just means that a piece of it is cut off. So this thing would have to be folded in such a way that it would give you like a perfect fit. The only difference is that it's like cut, a piece of it is cut off. And you can see that it could not be B, because if you fold B, when it comes back around here, this part would not meet perfectly with this part here. All right, and plus this little thing right here just shows that that's not like a smooth cut or anything like that. And for C and D, when you fold that, if I should fold this and bring it around to here, these pieces might meet, but then this incline here tells me that that's not cut like at a perfect angle or anything like that. Same thing for D. So the only answer could be A. So when we fold A, we will get a nice square prism, all right, with just a piece of it cut off. So the answer here would have to be A. And you can see how this just looks good. This angle looks similar to this angle right here, and you can fold this and get a nice clean fold. All right, so the answer for 13 should be A, but we can check that. Yeah, number for 13, the answer for 13 is A. Now for number 14, which of the following drawings show a rectangle equal in area to a triangle? All right, and we did this drawing in our plane figures of equal area playlist, so that's also on the channel as well, so you can also check that out. So in this case, the answer would be C, and the reason for that is because when you're doing a triangle equal in area to a rectangle, they have to have the same base. So like these here, these have the same base, so that has the same base and stuff like that. All right, and also you can just look, just by looking at it, you can see that this here, right here, would plus this would be equal in area to this section right here. D is out because the square and the triangle don't share the same base. B is out because, sorry, the rectangle and this is a square for D. It's not even a rectangle, it's a square. So that's out, and they don't share the same base, so that's out. All right, even though a square is technically a rectangle. And then this is out as well because that is not a rectangle. All right, so the answer for 14 would be C, and we can cross-reference that. Okay, so the answer for 14 is C. Now for number 15, which pictorial view below is represented by the orthographic views shown above? All right, so these are the orthographic views. So we have a side view and a plan view, and we're trying to figure out what the pictorial view is going to look like. All right, we know it cannot be A because you can see that right here is curved. All right, we have a nice little curve right here. All right, so it could not be A, and also it could not be C either because we don't have a hole in this part. We only have one hole on the drawing, all right, which is right here at the base right here. So we know that it could not be C. Okay, we also know now that it could not be D because the top isn't curved. All right, the top isn't curved. The base is curved, not the top. All right, so the answer would have to be B, where the base is curved, there's a hole right there, and then the top is flat, like is square like that. All right, so which number is that? Number 15. Number 15 is indeed B. Okay, now for number 16, it says the purpose of the construction above when completed is to A, draw a tangent to the circle from A, B, draw 2 tangents to the circle from B, C, draw an arc to pass through 3 points, or D, to find the mean proportional to AO and CO. So think about it. What do you think the answer for number 16 would be? All right, so according to this, the answer is A. All right, so we're trying to draw a tangent to the circle from A. Okay, so this is how you'd go about figuring out how you draw a tangent to the circle. So A is right here, and I want to draw a tangent to the circle. So this is the beginning of the construction of figuring out how we go about drawing a tangent, to this circle from point A. All right. Number 17 refers to the following diagram, this diagram right here. It says in the diagram above, the angle EFH is it A 30 degrees, B 45 degrees, C 60 degrees, or D 90 degrees? EFH. So this angle right here. And just by looking at it, you can tell that that's a 90-degree angle. But we can use AutoCAD to show you exactly why it's 90 degrees. All right. So look at this. If we have a circle, all right, and then we should cut that into a semicircle. Then if we draw a line from one end of the semicircle to touch the circumference and then go back to the next end, this angle is always going to be 90 degrees. And we test that. So let me measure this angle. So right here it says 90 degrees. All right, 90 degrees. That tells us that that angle is 90 degrees, and it doesn't matter where, as long as you draw a line from one end of the center line to touch the circumference and then go back to the next end, this angle is always going to be 90. And we can test that again. Exactly, 90 degrees again. So it doesn't matter where the point on the circumference is. It could be right there. That angle is still going to be 90 because it's the angle in a semicircle. All right, so that angle right here, this angle right here, is always going to be a 90-degree angle. Okay, good. So the answer is D, 90 degrees. Now for number 18, it says a cube with an edge of 80 millimeters is to be drawn in oblique projection. The length of the receding line in millimeters should be, and the answer should be D, 40. We can see. So it's number 18. Yeah, number 18, and the answer is D, 40. Now, why is it 40? The reason is this. In oblique projection, we have cabinet oblique projection and cavalier oblique projection. In cavalier oblique projection, you draw things as is. All right, you draw the receding lines as is. So if it's 80, you draw it as 80. But in cabinet oblique projection, you would reduce the length of the line, the receding line, by half. If you have a line that should be 80 and you're drawing it in oblique, in cabinet oblique projection, you would draw it 40. All right, so that's why the answer is D, 40. All right, number 19 refers to the following diagram. So this diagram right here. All right, which of the following is a true elevation of the drawing above? Which one of these drawings would show a true elevation of this? All right, so let's see. We know it cannot be B. All right, and it cannot be B because this is closed off, and we can clearly see that this section is opened, so it could never be B. When we're looking down at this, we know it cannot be D either, because this line here, all right, would not be, we're looking for the elevation, so this could not be the true elevation in no way, shape, or form, because it's missing so many parts. All right, and for D, for C, this is more like a plan view. All right, so when looking down, you're seeing the circle going through. I'm seeing this part underneath, and I'm seeing all that information, but this is like a plan view. All right, what we are looking for is the elevation, and this would not even be a correct plan view because there are too many broken lines here. So the correct elevation for this would be A. If you're looking at it from the side here, from a side view, you would see the piece underneath. You would see the sides looking like an L, and you'll see where the circle goes through this point right here. And so this is number 19, and it should be A, and it says that number 19 is indeed A right there. All right, good. So now number 20. Which of the following illustrates the normal of an ellipse? The answer for this is D. This is how we represent. C shows how we represent an ellipse using the concentric circles method. This is A, shows how we go about constructing an ellipse using the Trammell method. B shows how we go about constructing an ellipse using the rectangle method, and then D shows how we get a normal to an ellipse. All right, so this is the normal right here, and then this is the normal, and then this is the tangent right here. So we get this right angle triangle here, then we get the normal, and then we get the normal, and then we get the tangent. All right, so D shows how you get the normal of an ellipse. Good. Number 21, the spiral of Archimedes, and we did a drawing on this, Archimedean spiral. It says the spiral of Archimedes is defined as a plane curve generated by a point on a third chord as it is unwound from the perimeter of a polygon. Or is it the path generated by a point which revolves uniformly about a pole and has a uniform motion away from it? Is it a plane curve generated by the path of a point on the perimeter of a wheel as the wheel travels on a straight track? Is it the path generated by a point traveling in a place such that the difference of its distance from two foci is constant and equal to the transverse axis? And the answer is B. It is the path generated by a point which revolves uniformly about a pole and does a uniform motion away from it. And if you want to understand the Archimedean spiral even more, you can check out the Archimedean spiral video on the channel. All right, so number 21, it should be B, and it is indeed B. Good. Number 22. Which of the following patterns can be folded to form a square prism with an oblique top? Alright, we're trying to fold one of these to get a square prism with an oblique top. Alright, an oblique top just means that the top isn't exactly like flat. Okay, so it can't be A because that doesn't have a top. Can't be B because for B wouldn't have a top either, it just has the 4 sides. For C, you could fold C to complete a perfect box, but the top of the box would be flat. And for D, when you fold this here and you fold the sides, you will have a base and then the top would be an oblique top. So the answer should be D for 22. And for 22, the answer is indeed D. Alright, oblique top just means that the top isn't exactly flat, because C, the top for C would be flat. Now here, item 23 refers to the following diagram, this diagram right here. The diagram above illustrates the construction of, is it a circle tangential to 2 converging lines, tangent from a point outside a given circle, circle tangential to 2 lines at right angles, tangent to a circle at a point on its circumference. Now, for this, the answer is in one of the responses. Well, of course it is, because it's multiple choice. But when you look at C, it says that a circle tangential to 2 lines at right angles. And right here, you can see that these 2 lines are at right angles. And you can see that this little circle or little arc right here is tangential to these 2 lines right here. Alright, so this is like an obvious answer. So the answer for 23 should be C, and we can check that. So 23 is indeed C. Now for 24. The construction used in designing the bending jig illustrated above was that for obtaining is it a tangent joining 2 arcs? Is it a common internal tangent? Is it a tangent to 2 equal circles? Or is it a tangent from a point outside the circle? So we would have an arc here and would have a next arc here. Alright, so this would be a tangent joining 2 arcs. It should be A. So let's see. Number 24. Yeah, it is A, as you can see, because we would have an arc here and a next arc here, and then this tangent is joining the 2 arcs together. So yeah, that would be A. Now for 25, the points at which the bisectors of the angles of a triangle meet is the center of what? A point at which the bisectors of the angles, of a triangle meet is the center of what? Is it the 2 given circles, the inscribed circle, the inscribed circle, or the common tangent? Should be C, the inscribed circle for 25, but let me see. Yeah, 25 is C, the inscribed circle. So what do we mean by that? Alright, what we mean by that is this. If you have a triangle, alright, let's say you have a triangle, any triangle. Well, I'm not drawing like so much out of work. Alright, so let's say we have that triangle. Alright, it could be any triangle at all. And now if I bisect one of the angles, if I bisect 2 of the angles of the triangle. Alright, so let's say that I bisected like this angle by doing this, by drawing like a circle there, and then come in here to this point, draw a circle here from that point, and then draw the next circle here, and then copy in this circle, because the circles have to be the same radius. Alright, so copy this circle from here to this point there. Now what I would do from here now is to draw a line from that point to here and extend it like that. And we can do the same for our next angle. We start with a circle like that. The next circle anywhere here. Circle like that. Copy this circle. We're just bisecting the angle. And there are easier ways to bisect the angle because it's AutoCAD, so I could just select the angle, find out the angle of the have this angle right here and just draw the line to bisect the angle, but I'm actually just constructing the angle as if I was doing it manually. All right, and then draw a line through this point here where the two circles meet, and then extend it like that green line there. So now where those two lines meet, if let me just delete these circles that I use because I don't want the drawing to get too crowded. All right, so if I should draw a circle from this point, it should be touching the sides. It's a bit off by a little. All right, but what we use that for is for constructing the inscribed circle. All right, where the two lines meet, we'll get a circle that would basically perfectly fit inside of the triangle. But this is a bit off because the measurements are off. If I had just used the angles and just calculate the angles and just draw them like that, then this would have been perfect. All right, but it's because I was kind of doing a bit of manual drawing in AutoCAD, so that's why it's off by that much. But that's what I mean by the inscribed circle. All right, now number 26. It says the type of projection illustrated above is, and the answer is oblique. A. The reason why it's oblique is this: in oblique projection, the front part of an object will look flat. All right, almost two-dimensional, like this right here. See, this just looks flat. This part just looks flat. This is an actual circle that looks flat, but then the sides will slope at a 45-degree angle, and that's oblique projection. So number 26 should be A, and it is indeed A. All right, number 27. Which of the following is true of the construction above? Is it that IJFK is half the area of EFGH? Is it that EFGH is equal in area to IJKF? Is it that EFGA is half the area of IJKF? Or is it that IJKF is twice the area of EFGH? The answer is B. So EFGH, which is the rectangle, is equal in area to IJKF, which is the square. All right, so the rectangle is equal in area to the square, and we do have a drawing of this in the plain figures of equal area playlist on the channel. Good. So number 28, the ANSI, BS, and ISO regulations used in technical drawings referred to as these are international standards. Number 28 should be the international standards. All right, so these questions are questions that you'll see a lot on technical drawing, multiple choice questions. So it's just to understand that these are different standards, different governing bodies that set different standards, international standards for drawing and stuff like that. All right, number 29. When sketching pictorial, that's 29. When sketching pictorial figures, one should first sketch circles, draw all straight lines, construct parts separately, construct a box to hold the figure. The answer is D. You would construct a box to hold the figure. And that's how sketching works, because even though sketching is like you're just sketching and it's just random, but there's an actual technique to it. You sketch a box first, and then you sketch what you want out of that box. Number 30. Which of the following surfaces is developed in the shape of a T by unfolding or unrolling? Is it a square pyramid, a triangular prism, a rectangular box with a lid, a hexagonal truncated prism, or... So the answer would be a rectangular box with a lid. It will fold and open into a perfect T. And an example of that would be this right here. All right, so this would be a rectangular box with a lid, or a square box with a lid. All right, when it's unfolded, it would look like this, like a perfect T. All right, so we'll look at the first 30 questions on this paper, and then in the next video we will look at the next 30 questions. All right, so thank you so much for watching this video, and if you like the video, you can drop a like and drop a sub. We are very close to reaching 1,000, and I thank you all for your continued support. So Thanks for watching and do have yourselves a wonderful day.